Okay, so this is mini lesson 1.1K for consecutive integers. Our learning goal will be, given the sum of three consecutive integers, students will construct an equation and evaluate to solve for the three integers. So we might have some questions. What are consecutive integers? And how are we going to construct an equation to solve for them? So let's think about that. All right. So what are consecutive integers? So let's give this a little bit of context with the story. The ages of three sisters are consecutive integers. The sum of their ages is 45. Calculate their ages. So we have three sisters in this scenario, and we know that their ages, that they're consecutive integers, their ages. And when we add them all up, the sum is 45. We need to figure out what three numbers that are consecutive integers when we add them equal 45. So first of all, let's dive a little bit deeper into that term, consecutive integers. What does that even mean? So if we're dealing with consecutive integers, you need to understand what that is. So for three consecutive, it means that we're dealing with three terms. And yes, you can have four consecutive and five consecutive and eight consecutive, but the basis of it is three consecutive. And this actually is an SAT type question that we're going over today. So three consecutive sum, it means that you're going to take three numbers that are one after another. So one example is 1 plus 2 plus 3, and those are consecutive because they're one right after another. One, two, three. They're consecutive. They're continuous. There's no gap between them. They're consecutive integers. There's no integer other than 1 and 2 that's in between those. Okay, so it's 1, 2, 3, and they have a sum of 6 when you add them up together. Another example of consecutive integers, you can say, use the example 7, 8, 9. Okay, those are consecutive integers as well, and they have a sum of 25. So had this said there's three sisters whose ages are consecutive integers and the sum of their ages is 25, we would have been able to say, oh, they're 7, 8, and 9 years old. Those are the three sisters. They're born one after another. It's consecutive. Okay. Now, today, while today we're going to only focus on three consecutive sums, there are also three consecutive even and three consecutive odd that I'll give you a clue into right now. So for consecutive even, it just means that you start off at an even number and you're only going to pick the next consecutive even numbers. So since 5 is not even, I have to skip it and go to the next even. And since 7 is not even, I have to skip it and go to the next consecutive even number. So 4, 6, and 8 is an example of consecutive even. Just like down below, if we look at consecutive odd, we're going to start at, for our example, we can start at 5 and say 5. I have to skip to the next odd number, then skip to the next odd number. 5, 7, 9 is an example of consecutive odd. Okay, so the difference is here is that when you're dealing with just a consecutive sum, it's one after another. All right, it's the difference between 7 and 8 is just one more. The difference between 8 and 9 is it's just one more. However, when you deal with consecutive even, you actually have to say, well, to get to the next one, I have to add two more. And all it means for consecutive even is you're adding two more and you're starting with an even number. And for consecutive odd, you're adding two more, but you're starting with an odd number. Okay. For today's lesson, though, we're going to really focus in on just these two up here. We're just going to learn the basics of consecutive sums, and we'll add to that knowledge as we go on. Okay, so let's dive a little bit deeper now. The ages of three sisters are consecutive integers. The sum of their ages is 45. Calculate their ages. Same exact problem as before. So we're solving for the ages. That's what we don't know. In algebra, we don't use a big old blank box for what we don't know. We use an X. So here's the age of the first sister. Okay. Um, we don't know her age, but we can say this is the age of the first sister. Now, what's interesting is that even though we don't know her age, we know that the second sister is a consecutive integer. It's got to be the next one that follows. So let's take a step back. Doesn't matter which one of these integers I choose. If she's 4, then the next sister has to be 5. If she's 9, then the next sister has to be 10. Okay? If she is 2, then the next sister has to be 3. No matter what, she's going to be the next sister, the middle sister is going to be one more. So I'm going to say that the next sister is the same unknown age as her previous sister plus one more year. Okay? So this is the first sister. This is the second sister. And for this third sister, we know that she's got to be at least 1 year or exactly 1 year older than the middle sister. So I can say that this right here represents the age of the oldest sister. So all in all, let's label this out. So let's label our work as we model. So we can call this the youngest sister. We'll call A the youngest sister. So she's the youngest, and we'll label her A. And this is the middle sister. She's 1 year older because they're consecutive integers, and we'll call her B. And here's the oldest sister, and we'll call her C. Okay? So the youngest sister is some unknown X, but we do know that the middle sister has to be exactly 1 year older than that sister because they're consecutive integers, and the oldest sister has to be exactly 1 year older than the middle sister. So with that being said, we can actually move these around to see how to solve for their age all together. So this is what I mean by that. Let's move out some of those values now that we know what each of them represent. And if we're looking at this as combining like terms, I have 1, 2, 3 x's. So let's move those all together. Let's put our like terms together. I'm going to put this here and then slide this one over. Here's the next sisters, and I'm going to put all of our like terms together. And what you should see is an equation forming. Because what this is really saying is that what I have is all together, if I add up all of these, their age is a sum of 45, right? All of these are equal to 45. Well, if all of this equals 45, what does this portion equal? What's this part equal to right here? If this whole model is equal to 45, what does this one have to be equal to? Well, I know what this is. This is 1, 2, 3. So I can take 3 away and determine that this part is equal to 42. So now I just have to figure out if this portion is equal to 42, what number, when I add it 3 times, equals 42? What number is that? So let's look at this algebraically a little bit, all right? Down below, we have our algebraic model. What we're saying is that 1, 2, 3 x's plus 1, 2, 3, 1, so plus 3, is equal to 45. This whole thing is equal to 45. Now, if I wanted to know just the this part, just for the 3 x's, what we did here is we subtracted out 3. We did an inverse operation and we subtracted 3 out. So now I have 42 is equal to 3x. And unfortunately, I'm running out of space. I'm going to move this over here. So let's say that 3x is equal to 42. Okay. And that being said, what is one of those x's equal to? Well, let's divide those by 3. We have 3 of them. We know they add up to 42. Let's divide them by 3 to find out what 1 is equal to. 3 divides into 4 1 time, and 3 divides into 12 4 times. So that's 14. But we're not done yet. It said calculate their ages. So let's go back here. If the first sister is 14, and their ages are consecutive integers, we know that the second sister is the first sister plus 1 year, so she must be 15. And the third sister is the middle sister plus 1 year, so she must be 16. Okay? On the next page, we're going to take a moment and stop and check our work and calculate it. Sorry, check our work, yeah. All right, so let's move on. Okay, so what we did before is we said that we created the equation that 3x plus 3 is equal to 45. All right, and we modeled this by saying that the first sister was x because we didn't know her age. The second sister was x plus 1. And the third sister was therefore x plus 2. So there we have it. Even though we don't know, well, now we know, but even though at the time we didn't know, we can still conceptually understand what their ages are if they're consecutive integers. So this is the youngest sister, this is the middle sister, she's 1 year older, and this is the oldest sister, she's at least 1 year older than the next sister and 2 years older than the youngest sister. We solve for their ages by subtracting 3 from both sides and getting 42 is equal to 3x. Then we divided both sides by 3, and x is equal to 14. But remember, we were responsible for finding the ages of all of the sisters. So if x is equal to 14, then this sister is 14 plus 1, plus 1, and this sister is 14 plus 2. So we can say that sister A, the youngest sister, is equal to x. Sister B is equal to x plus 1. And sister C is equal to x plus 2. And those are the ages of the three sisters written as equations. Okay, so if the youngest sister is x years old, describe the ages of the other two sisters in terms of x. Write an expression for the sum of their ages in terms of x. So we may say here that their ages are x plus 1 plus x plus 2 is equal to 45. Those are the ages of the three sisters in one equation. We can also group our like terms and say I have 1, 2, 3 x's plus 3 is equal to 45. These are equivalent expressions. Okay, let's take a peek at one more example before you try one on your own. Solving for a word problem involving consecutive integers. This is what your assignment afterward is going to look like. So 3 consecutive integers have a sum of 72. Find the integers, okay? So we're solving for these integers. We know that there's 3 of them and they have a sum of 72. So our first one is going to be x. Our second one has to be exactly 1 digit higher because it's a consecutive integer. So our second value has to be x plus 1, and the third number has to be exactly 1 more higher than the middle one. So that one's got to be x plus 2. Okay, so here's my first number, here's my second number, here's my third number, They're consecutive integers and they have a sum of 72. So I'm going to set this equal to 72. So here is my equation. Here's my equation with an equal sign of my consecutive integers that have a sum of 72. X, my second number, x plus 1, and my third number, x plus 2. These have a sum, so they all add up to 72. Now, one of the first things I can do here is I can combine my like terms. I have 1, 2, 3 x's. So I have 3x. And then I see I have one constant here, and I have two constants here, so I can combine those as well and say I have 3x plus 3, which is equal to 72. And now I can solve for them. So similarly to before, I can give the example and say I have x for my first one. I have x plus 1 for my second one. And I have x plus 2 for my third one, or for my third integer. Okay? So this is the first number, this is the number that's right after it, and this is the third number. Okay? All written in terms of x. Okay? So here's my x plus 1, and here's my x plus 2. Now, when we combine like terms, all we did is move the like terms, all the pieces that were the same, near each other and say that, oh, okay, here's my 3x's. Let's put all those together, and here's my plus 3 over here. All right? And I know that my 3x's, let's move these over, plus my 3 1's, I know that this whole thing I can visually actually see, because math is so visual, I can actually see that all of those have a sum of 72. So then again, there breeds the question, well, if all three of these add up to 72, what do just these ones add up to? If all of these add up to 72, then what's this portion? Well, this portion is 3, right? 1, 2, 3. So this one over here has got to be worth 69. Well, what three numbers, or what number do I repeatedly add x plus x plus x? What number plus itself 3 times equals 69? All right, so you can divide that to see what it is. Let's show that what that looks like using some algebraic expressions. Okay, so I thought I was recording and I wasn't, so I'm hoping I'm picking up in a good place. So looking at these, we can combine our like terms. We have 1, 2, 3 groups of x. We can say that we have 3x. We have 1, 2 constants. We can combine those for 3, and we set that equal to 72. We subtract 3 from both sides to figure out what just that portion, just those 3 x's are equal to, and that gives us 3x is equal to 69 because those cancel out, all right? And now we can divide by 3 to find out what 1x is equal to. So x will be equal to, for 69 divided by 3, 3 divides into 6 2 times, 3 divides into 9 3 times, so I have 23, or 3 really divides into 60, I should say, 20 times, and 3 divides into 9 3 times, so 20 plus 3 is 23. However, we're not done yet. It said find the integers. That's plural. I found 1. I need to figure out what the other 2 are. So if x is equal to 23, then that means our next value is 23 plus 1, which is 24. And our next value is 23 plus 2, which is 25. And there are our consecutive integers, 23, 24, and 25. And to check, just add them up. We should always be thinking and checking our work, okay? So 3 and 4 make 7, 7 and 5 make 12, carry the 1, 3 2's make 6, plus 1 is 7, and our check works. So our 3 consecutive integers are 23, comma, 24, comma, and 25. We're just going to list them. Those are our 3 consecutive integers. Final answer. So on the next page, you're going to do your own example. Make sure that you type your answer in and separate them, your integers, with commas. Okay, so the sum of 3 consecutive integers is 36. Find those 3 integers. Make sure that you separate your answer with a comma. You should have your first number, comma, your second number, comma, your third number when you type in your answer. Good luck. Great. Now, the last thing you need to do is practice. All right. You just saw a new skill. You've got to reinforce it with some practice. So move on to Alex and do assignment 1.1K on consecutive integers.